Okay, cool. So, three main components to TPM keys. Creating them, certifying them, and using them. So, when you're creating a TPM key, the first question you need to ask yourself is, what kind of key do I need? In part because there are two different ways to create keys, one of which is an identity key and one of which is everything else. There's technically three, but if you're not worried about certified migratable keys yet, that's the advanced class. Trust me, that's the advanced class. So, a quick review, and a little more detail than we covered earlier today. Awesome, here's back. So, identity keys, also known as AIKs or attestation identity keys, sign data that comes from the TPM, not user data, although we'll get into how you can do that anyway tomorrow, but signs things like quotes, certified key certificates, other reports from the TPM. If you're doing tick counters, you can use an identity to sign it. You can have many identities. This is not one identity permanently. There are also signing keys, which can be used to sign user data, and in fact have much more format flexibility than identity keys do. There are storage keys, which are used for encrypting data, and I will note that data here includes other keys. There are also binding keys, which in a funny technicality are only used to decrypt data. Storage keys also decrypt data, of course, but the binding keys are generally used if you've got data coming in from another platform. You can use a binding key to decrypt it, whereas storage keys are for encryption and decryption on the local platform. There are also legacy keys, which can be used for signing or encryption, but they are noticeably lower security. They're there for backwards compatibility. These are basically a 1.1 TPM key. They are only usable in some commands. And a note here, if you've got your TPM configured in FIPS mode, which is to say meeting some minimal levels of security, even though it isn't technically FIPS approved, legacy keys can be created. In general, when we see legacy keys, it's because someone has created a key in software and imported it into the TPM. Program. This is one of the ways you do it, is you could say, this is only available in locality 3. PCR, yes? Yes. That I will get to how those PCR constraints are enforced a little bit later, but in short, whatever you specify here must be true for the key to be used. It can be loaded in any state you like, but it's never going to be used until those constraints are met. And the PCR constraints, I will note, whereas we usually say if it's a quote, we're going to say all 24 PCRs. Usually if we're talking about keys, we do not use all 24 because those are the constraints that must be imposed whenever the TPM is used. So any more than you absolutely have to have is one more opportunity for the key to become unusable, and you've accidentally denied of service to yourself. Whoops. So for example, if we've got a key that is supposed to be locked to that pretty little virtualization dynamic root of trust for measurement architecture we had before, we're going to lock it only to those PCRs set by the dynamic root of trust for measurement, and we are not going to depend at all on the PCRs set by the static root of trust for measurement, because after all, those values no longer matter. If we set the key to depend on all 24, suddenly it would require both to have operated correctly, and we're missing a lot of the advantage that we got from saying we're depending on the dynamic root of trust for measurement. This is when you can specify whether a key is migratable or non-migratable, and note, none of these options change after the key is created. You cannot update the PCR constraints on a key any more than you can change whether it's migratable or not. This means that the PCR constrained keys, if you update your machine in such a way that the PCRs change, you're going to have to create a new key. This is part of why having a convenient built-in certification mechanism is so important for the TPM. This is why PCR-locked keys are a thing to use carefully. They are tremendously powerful and tremendously fragile. In general, we do not recommend. You can set PCR constraints on your storage root key if you're feeling like bricking your TPM. Why anyone would do this, I don't know. But theoretically, it's possible. In general, PCR constraints, do not use them unless you have a specific application with a specific goal in mind and your system is built to accommodate it. So if you want to say this key is only usable by this user, or with these authorization values after event X has happened, you can start doing things like that, but you're risking it if your values change, it's dead. 2.0, we're going to start seeing much more flexibility. 2.0, we're going to start seeing PCR constraints that are things like these PCR constraints or some other set of PCR constraints approved by public key X. So I can have a central authority that can update the constraints on my key. Okay. Or we can start saying, PCR 13 is A or B or C. So there's much more ability to not trivially break things in 2.0, but trade-off, lots more complexity. This is a simple equals or not equals. That you start evaluating Booleans and also certain keys, like signing keys are the one that really has this show up, have options. So signing keys, there's 3 different signature schemes you can select. We're going to go into a lot more detail about that tomorrow morning. In general, look at the key in question to determine what options it has. Most of them are not especially surprising. That one happens to be. In addition, when you create a key, you have to provide a parent key, which needs to be a storage key already loaded into the TPM. Conveniently, the SRK is a storage key already loaded into the TPM, which is part of why we see it used as a parent for all sorts of things. The first keys you create, it has to be the parent for, because after all, you don't have any others. But you can create, if you want to have a password-protected series of keys where you have to know the password in order to unlock them, you can create another storage key with the password, and that's where that sort of authorization comes in. Create wrap key outputs a key blob, which contains an encrypted private half and all of this data, which the user is responsible for storing safely, usually on the disk, although you can load a limited number of keys into your TPM's memory and lock them there if you're the owner. Why is it the non-migratable keys are exportable? That is counterintuitive. Here's the thing. They're not exportable. They just live off of the TPM. I wasn't covering that until you asked the question. The question is, why are non-migratable keys exportable? So this key blob is effectively, there's nothing private in it that's not encrypted. I can publish a key blob in the New York Times and be completely confident that that's fine because only my TPM can load it again. I mean, not brute force attacks, but the key blobs are protected by a local key. So when I say this lives outside of the TPM, that's not it can be exported to other TPMs. That's not other people can use it. It's the TPM is small and has limited storage space. So it encrypts things and has the user store them elsewhere. Now this means that we can do things like they might be stored on a local disk. I might have applications where there's a database somewhere that has a key blob for each machine, and part of the request is, by the way, please sign this data with this key. That's fine. If you're not the machine in question, you can't use that key blob anyway. There's not actually a security heading there. So we don't really care how these are maintained, but they're maintained outside of the TPM, and then they're protected with the parent. Identity keys are a little bit different. Make identity, unlike create wrap key, must be authorized by the owner. Also, make identity doesn't let you pick a whole bunch of things. It will always be a 2048-bit non-migratable key. You can pick what the parent is. Maybe, actually, the parent may always be the SRK now that I think about it. You can choose whether or not it has a key password. You can impose PCR constraints on it. But fundamentally, the big choices that you may choose to shoot yourself in a foot with in normal keys, i.e. creating it too short, creating it migratable when you didn't mean to, you cannot possibly do with an identity key. Identity keys are inherently just a little bit more secure than other keys, not because you can't create another key that has the same security properties, but because you can't not create an identity that has good security properties. The other thing that is different here is I note here there's a privacy CA to create a signing request form. We're going to talk in the next section about how we certify TPM keys, and identity keys have a special certification mechanism that uses a special protocol with a special kind of CA. I'm sure you're really excited about all of this because we're breaking standards right and left. This command outputs both a key blob and a special format certificate signing request that can be sent to the CA. You do not actually need to keep this signing request. You can generate these signing requests without having the TPM involved. So I'm not concentrating on this very much. But it's worth noting that this is one of the options you have to provide, even if it's a junk key. So the key blob is the exact same format as the create wrap key outfit. So these are all, this is not a wrap key. It's just a specialized kind of wrap key that you had to create using a special command with special permissions. There you go. The certificate signing request is not a self-signed signing request from X509. It's part of this other protocol that we'll get to in a moment.